During wartime, you know, when the Romans were invading other populations, the civil engineer was always there. Civil engineer was the guy who designed bridges so they can go through, you know, rivers, dams, walls that went around the city to protect them. So the civil engineer used to be a military engineer, and then in modern day, because they called us civil engineers. I'll explain why. When the civil engineering came to the United States, the first civil engineering school was West Point Academy. West Point is a military, right? The difference is that if you got into the civil engineering program, you did not go for a grade. So you were never part of the Army or the Marines, but you were part of them, and it's called the Army Corps of Engineers, but you never had a strike. And that's where the word, we were civilians. So that's where the word, we were engineers, we were civilians, civil engineer. Okay?
You want me to keep walking back around?
So civil engineers deal with 5 main aspects of construction, from structural, you know, bridges and, you know, steel buildings and skyscrapers, soils, hydrology, what you guys just did, transportation, traffic, you know, traffic lights, and then construction in general. Today we're going to demonstrate some soil. So we're going to do a sieve analysis, which Matt is going to demonstrate in a few seconds. Yes?
Do you guys like design it and build it, or do you guys just design it?
We usually design it, and now it's becoming also building management. So that's the construction part. So we usually design things, and we can build it. You know, we can also monitor the construction part, make sure that it meets the specifications of the job site.
So who are you that actually like does the construction?
Those are just contractors. Different types of contractors. If you're doing concrete contractors. If you're doing asphalt contractors. If you put in pipes, pipe layers, and so on and so forth. So there are different type of contractors. There's some that are called general contractors. That means they do everything. Okay. So today we're gonna sow soil. We're gonna look at how we measure the permeability of soil, and I'll explain to you when you get to that station. And then we're gonna break some concrete back there, and we're gonna show you how we test concrete. Okay? One note, if anybody of you guys are interested, Wayne State University has an articulation with Macomb College. We have a construction program at Macomb College that is a 2+2, 2 years at Macomb, 2 years at Wayne State. And if you're interested, it's a very good program. Bachelor of Science in Construction Management. You can talk to the Wayne State people, you know, in the other room for lunch. All right, so he's going to go ahead and show the soil first.
So this is called a sieve analysis, and basically it separates dirt. You can see there's all different size stones and sand and things like that in here. And what you do is you scoop some up in the thing, your little metal scoop, put it in here, and you put the lid on. You see on the front here it says ASTM on here. You'll hear Joe talks about that a lot. It's ASTM standards. It's kind of like the people that set up the rules for civil engineering. They decide the way things are supposed to be done, the kind of tests you do, and how you do them. So you tighten it down like that. And this is a shaker. I'm going to turn it on so it shakes the dirt, and it drops through all these different screens and it separates it. So the big stuff is stuck on the top, the smaller one, the smaller, until finally you're just left with the sand. And then finally there's a solid one at the bottom. The bowl at the bottom catches the finest stuff, yeah, like that. So, yeah, the clay. The clay's the finest stuff. So then you know what kind of dirt you're dealing with, because the dirt in every location is not the same. So before you start building, you need to know what kind of soil you're building on top of. So like when you see on the news where a building fell down or it's leaning, the Leaning Tower of Pisa, you know, a mistake was made and the building started to lean because the footings, the foundation wasn't big enough. So this is the kind of thing this tells you, so you know what kind of dirt you're dealing with, and you know how big the foundation needs to be and how deep it needs to be and things like that.
All right, so come over here, and this is a different station. So what he was just talking about, basically, these are the three different main types of soil. You have a gravel, which we call, granular soil. So you can actually feel the type of grains, right? Sand is similar, like sugar. You can still feel the grain distribution. Then you come to clay. Clay is more like a chalk. This is it's a solid piece of clay, but if I break this off and I crush it, you'll see that clay is like chalk. This is the finest type of soil, right? So they all have different engineering properties, and this is what we do. There's this machine here, for example, is called falling pad permeability machine. So civil engineers will play with this in labs all the time. Very simple test. We open up this. We have gravel in here right now, but we put in whatever soil we get at the field. We compact it. We close it up, and we fill this big beaker with water, and we want to saturate this soil. Okay, once it's saturated, we fill up this beaker here, and what we do is we close the valve, and we fill it up, to a known point, like 80, 90, 100, whatever it is. Once we're satisfied, what we're going to do is we're going to take a stopwatch, and we're going to open up the valve, or stopwatch. Usually two people do it, right? And we're going to monitor how much is dropping and how fast it's dropping. When water starts coming out of here, we close the beaker, right? And we count how many seconds it took to fall a certain distance. And by doing that, we know how fast it's going through the soil, right? Feet per second, meters per second. This over here is around 20, 30 minutes to get through. This one over here is about 2-3 minutes, and that one over there is seconds. All right. So we can say that this is a very low permeable soil. This is a medium permeable soil, and that's a high permeable soil. Permeability is the speed in which water goes through the soil. Okay. In everyday life, this is used for septic fields to figure out if you're in a septic area, how good the soil is in absorbing water. So obviously, if you have this in your backyard, clay, you ain't gonna put a septic field in your backyard. Or it has to be really, really big. If you have sand or gravel, then it's a slam dunk deal. If you put a septic field for an average house on a clay bed like this, it would probably cost $50,000. If you put a septic field in this type of soil, it's probably $2,000–3,000. So you can imagine how important it is to know the permeability of the soil, before you start, before you buy a house or you start building. So we're going to come over here. We're going to break some concrete now. These are cylinders that were given to me by MDOT. MDOT is Michigan Department of Transportation. This was done on highways, all right? And what happens is the civil engineer, or the technician in this case, will go to the job site, and you see these plastic molds? We'll have a bunch of these plastic molds in the back of this truck. And what we do is when concrete trucks come to the site, we fill these molds up, and there's a procedure how we do it, okay? We use a rod, and there's an ASTM procedure. So we fill this mold up, and we keep it at the job site for 24 hours. After 24 hours, we bring this mold, we go back with our trucks, and we fill up the trucks, and we bring the molds to the lab. In the lab, we put them in water. You see there's a truck of water there? Looks like a horse truck. We put them in water, and we cure them between 7 and 28 days. So we'll keep them in water for usually, the right procedure is 28 days. After 28 days, we strip them. We use a stripping tool to strip them. It's basically something this easy, right? And we have a hammer, and we just strip them. Once we strip them, we have our sample. And our sample, we test them in a testing machine, which is something like this. If you come a little closer, I'll show you how we're going to break them. So this is a destructive testing. So we're going to determine the PSI the pounds per square inch of this concrete. If you ever bought concrete, you know, the first thing they'll ask you is how much and how strong. You can get 2,000 PSI concrete, you can get 3,500 PSI concrete, you can get 4,000 PSI concrete. The only difference is the mix and the type of aggregate that goes into the concrete. So if I design a road and I want my road to be 5,000, 6,000 PSI, I want to make sure that I'm getting my money's worth. And the only way you can make sure is by doing destructive testing. All right, so I'll take samples at the site. Usually the owner will hire a civil engineer to go out there and sample it. We'll take usually 5 samples per truck. So a stretcher road that is a mile will have 200 samples. And then we'll put them in water, we'll cure them, and at the end we'll break them, and then we'll do a report telling the owner whether he got his money's worth or not. All right? So what we do is we put a jacket on it. Not everybody puts a jacket, I do, because when it breaks, it shatters. So you can get, concrete all over the place. We put these stainless steel, they're very heavy duty, very heavy, and we put these caps on them, all right? So once I put the caps on, I put it on a testing machine, and it looks very similar to this. There's different types out there. And we close the cage. Now, this machine has a digital readout, and basically we zero it, we turn the machine on. It's a very simple operation. It's got a lever that makes the piston close. So what we do is we're going to go to fast advancement until we see a load on it. And then we go to slow advancement. With this valve here, we're able to control the speed of the load, like 400 pounds per second, 500 pounds per second. And it's going to make a noise, like sometimes it makes a bullet noise. That tells us that it broke.
Maybe you should have warned me.
I did. So it broke, right? And we retract the piston. We shut off the machine. We take this out of here, and now this particular concrete had 73,000 pounds on it. So pretty a lot of load. Now, in order for us to get 73,000 pounds and convert it to PSI, we have to divide this number by the cross-sectional area, which this is a 4x8, cylinder, and it has a cross-sectional area about 12.57 inches square. So we divide that by that, and we get pounds per square inch. Okay. We'll then analyze our blade, and we're usually looking for a cone. And all of these have been coning today, so they've been good samples. This is actually very good break. But the coning tells me that this was a compression break. So it didn't. If it's tilted on one side or it's got too much on one side, you would have a little chip off. This is telling me that it was a good break and it was a compression break. And this probably is around 4,000 or 5,000 pounds PSI. Questions?
That's good. Thank you for doing that.
No problem.